Hey guys, welcome back to our flipped video lessons. This is Unit 1, Target 4, and we are going to be simplifying algebraic expressions. And actually, I had a friend stop in that's going to help us out with our lesson today. I'd like to introduce you to Jimmy G. Buckets, otherwise known as Jimmy Butler, player for the Chicago Bulls. Jimmy, thank you for being here. Are you excited about helping us with some math today? Oh, that's awesome. That's awesome. Well, while we got Jimmy here, let me just ask him a few questions. Are you pretty excited with the addition of Paul Gasol and Nikolai Miracek and signing Kirk Heinrich and getting Derrick Rose back? Oh, man, I'm pretty pumped. Are you guys going to dominate LeBron James and the Cleveland Cavaliers this year? Oh, man, Jimmy is just getting me fired up for some NBA basketball. But in the meantime, let's learn some math. Jimmy will drop in with us a few times throughout the lesson a little later on. So we've worked with expressions in our last lesson, but we worked with known values. We always knew what the numbers were. We could put them in a calculator. We could count them on our fingers. But if you look at the expression below, 8x minus 9y plus 10 has some variables. We've worked with the definition of a variable before. It's a value that we don't know. So how do we add, subtract, multiply, and divide when we're dealing with variables? How do we simplify? The first question we have to ask is, what operations are there that we might have to simplify? Addition and subtraction are obvious, so you might be tempted to say that there's only two. But in reality, there's actually four operations in this expression. We have the multiplication symbol hiding in between the 8 and the x and the negative 9 and the y. This is our ninja operation. When multiplication starts hiding in between a number and a variable and a variable, a number in parentheses, right, it becomes a ninja. And we talked about we have to watch out for those ninjas to make sure they don't sneak up on us and stab us in the back, right? That would be bad. Right, Jimmy? Ninja stabbing you in the back bad? Good, Jimmy agrees. So, now that we've identified our operations, let's ask the question, can I actually perform them? Can I actually simplify them? Well, with the multiplication, we can't. We can't take a known value like 8 and negative 9 and actually multiply that with a factor of a variable, x or y. We just have to leave them as they are, 8x and negative 9y, with a coefficient and a variable. So that brings us to the addition and subtraction. Can we actually combine these terms? Can I take the 8x and the negative 9y and combine them together? Can I take the negative 9y and the 10 and combine them together? Well, to answer that question, we have to learn a new vocabulary word, a new term. And that term is a like term. So if terms are like terms, we can combine them. We can add or subtract to put them into one term. But what makes terms a like term? Well, terms with exactly the same variables with exactly the same exponents. And notice we use the words with exactly the same. It's got to be exact. Pretty much like this picture of Kevin from The Office and this happy seal we have here. They look pretty much identical. One important thing to remember here is that coefficients have absolutely nothing. That's capital letters there. I am yelling that at you so it sticks in your brain. There is absolutely nothing to do with our like terms. They are only play a part in us simplifying them, the multiple terms, into one term. But making them actually like terms where we can combine them, nothing to do with it. Right, Jimmy? Coefficients have nothing to do with like terms. Yeah, remember that face right there. Nothing to do with them. All right, so now that we've talked about like terms, let's actually look at some actual terms and start working with this definition, not just as words in a sentence, but with some actual terms and some numbers, variables, and exponents here. So if we look at our list, we have three lists here. When each list has a number of terms. And what we would ask you to do is look at these lists and pick out which terms would be like terms. So let's look at our first list. We've got 7x, negative 3y, 6x squared, and 12y. So which terms there do you think are like terms? I'll give you just a second here. Did you say negative 3y and 12y? I hope you did. We can see that they have the same exact variable, y, and they have the same exact exponents, right? It doesn't seem like they have any exponents. We'll get to that a little bit later in the year. But for now, you can see it's just y and just y. So those are like terms. Now the 7x and the 6x squared have the same variable, but you can see the 7, it's just x, and with the 6, it's x squared. Those are not like terms. We can't put those together. It's got to be the same variables with the same exponents. Let's look at our second list. It's a little bit longer here with multiple variables in some of the terms. We got 3a to the fourth b, we got 3b, 6ab, 9a, negative 3b, and 7a to the fourth b. So which terms on there do you think are like terms? Let's see how you did. So we can see that 3a to the fourth and 6b and 6a to the fourth b are like terms. Again, they have the same exact variables, a and b. The a's have an exponent of 4, and the b's are just b there for both terms. That makes them like terms. 3b and negative 3b are like terms for the same reason. Now notice, even though 3a to the fourth b and 3b have the same coefficient, they're not like terms. It doesn't matter if the coefficients are the same. That doesn't make them like terms. Okay, let's try one more list down there. You can see the terms. We've got 5 of them. So which terms on that list are like terms? Just 2. We just have one pair here. Negative 2m to the third p squared and m to the third p squared are our only like terms there. And remember, there actually is a coefficient in front of that m to the third p squared. That's our ninja coefficient. It's actually 1 m to the third p squared. So make sure you're remembering that. Notice, even though every term has the same exact 2 variables, m and p, there's only 2 terms that have the same exact variables with the same exact exponents. Right? And this is something that's be really important to remember as we're solving single variable equations, as we're working with multivariable linear equations, as we start working with quadratics, lots of different types of equations and inequalities. Like terms are going to be an important part of that. So now that we've talked about our like terms, let's actually get down to simplifying our algebraic expression, right? And I want you to come at these like Jimmy Butler comes at LeBron James on defense. Isn't that right, Jimmy? You just lock him down, shut him down, and he gets no looks at the hoop. That's what I like to hear. I like that confidence in Jimmy. But I want you to have that same confidence with our algebraic expressions here. So we're going to work on simplifying. So if we look at A here, we have 6x plus 9b minus 3x plus 5b. So which terms, which operations can I actually perform? Let's take a look here. We can see that the 6x and the negative 3x are like terms. They have the same exact variable with the same exact exponents. So I can take the 6x and the negative 3x and simplify them, 6 minus 3, to just positive 3x. The 9b and the 5b are like terms, so I can combine those, 9 plus 5, to 14b. Now at this point, I can't do anything else. The 3x and the 14b are not like terms. This is as simple as I can make this expression, and we have to know when to stop. Right? Think about driving a car. It's just as important to know how to hit the brakes as it is how to hit the gas, maybe even more important. So getting started with the problem is good, but you got to know when you're done. When are you fully simplified? And this is it with 3x plus 14b. So let's try B and C on your own here. Go ahead and hit pause, and we'll come back and see how you did. Ready? Pause. So let's check here. Let's see how we did. So in B, you can see we should end up with 6y plus 13y squared minus 4. Notice the 6y and the minus 4 didn't change because there's no like terms. We just brought those down. They stayed the same. But the 7y squared and the 6y squared combined to 13y squared. For C, there are no like terms. Every single term has either a different variable or a different exponent than the other terms, which means it's as simple as we can get it. We can't do any of the operations, the adding, subtracting, the multiplying in this expression. And that'll happen sometimes. Well, that brings us to the end of our video. And as Porky Pig would say, that's all, folks. That's Mr. Doll and Jimmy Butler signing off.